Testing 1 2 3. Testing, 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 testing. All right. All right, ladies and gentlemen, welcome to the stream. I'm going to close out that. Close out this. All right, welcome in. Anyone who's watching right now? No one. All right, so what we are going to do is I wanted to have a Bitcoin talk today. So what I'm going to do is close out this, reject that. We are going to open up some new tabs, and so I came across an interesting question. Okay. And okay. So what I did was I was planning on give me a second to get in everything right now. All right, we are home. All right, so I got Replit open, and I had Answer the Public open. Okay, so what I searched was in Answer the Public, which gives you 3 searches a day for a free account. This is how I kind of generally do kind of a really basic kind of SEO kind of research of like YouTube topics. I can either go to Google or YouTube. I can click either or, and I can just, what I do is I simply just plug in some kind of topic I'm interested in personally, and I keep it down, distilled down to one keyword. And what this does is this kind of sources the SEO content, which is SEO stands for search engine optimization, for those not familiar with that term. What this distills down to is Answer the Public. It is what people are plugging into search requests the most. So when they go into Google, when they type in search, if it has this related keyword, what are they asking related to in their question? And so it kind of breaks it down into questions or statements or specific keyword pairings. It's not just like keywords. Search engine optimization research is typically done on figuring out trends of what people are searching for in Google. This is related to what questions people are asking. So for YouTube, I just typed in Bitcoin, and it gives me relevant charts data. So there is a total of 139 recently Bitcoin related questions, and it shows you kind of the relevancy. Okay, and then on this one it's 70 prepositions, and then 58 different comparisons. So for comparisons, people are asking, you know, Bitcoin and Ethereum. So people are probably wondering what the difference between Bitcoin and Ethereum, Bitcoin and cattle, Bitcoin and friends, stuff like that. So comparative questions would be, you know, this or that, this like this versus that, this and that. So those are comparisons. And so it shows you the ranking of how people do it. And then you can go further into it, other related questions and stuff like that. But I usually typically stick with questions. Why I like questions is it gives me a framework to build human avatar for me to speak to. I have my own experience and knowledge set as a human, as a person, and what I like to do to kind of bring out that message is I can't figure out problems, and it's right now I'm still getting new to it. It's hard for me to kind of build a audience avatar of who this message is for. So what I do is I just look at like what are people asking. So I like to go to the questions. Okay, so one question in here, as I was going through it, kind of stuck out to me. There's a lot of different ones. Who made Bitcoin? Who is Bitcoin owner? Why Bitcoin has value? Will Bitcoin hit 1 million? So a lot of different questions. One question that stuck out to me is how Bitcoin works and how Bitcoin mining works. There's one, and then there was another one. It was related to can I mine on my phone? I'm not sure if I'm seeing it no more. Work started mining, made wallets, miner, how Bitcoin miner works. I think there was a question here, can I mine on my phone? Can Bitcoin can app be legit? Miner, are Bitcoin miners worth it? Can go here. I'm not seeing it no more. It might have. Well, I thought I saw it. It was related to can you essentially mine on a phone? And I really liked that question. The way why it inspired me, it was technically you can. Is it efficient nowadays? No, because of kind of the core functionality of Bitcoin. Let me pull up some information for you. So Bitcoin has a couple fundamentals of how it operates. And let me pull up this first. Okay. Price, hash rate. All right. So what is hash rate? Hash rate in Bitcoin terms, you'll hear the term proof of work. And what proof of work is a simple computer function. It is the action of a computer algorithm essentially guessing a number. And then getting rewarded for that number. And so that's, in simplest terms, that is what Bitcoin mining is, and that's how Bitcoin is created and issued into the network system. Is there's a network of computers, okay, that are just running simple calculations, and all they're doing is going to these kind of like a central node that produces this number, okay, and it's converted into using a SHA-256 algorithm, and then it is made into a very difficult number depending on how much competition is. So it's just a guessing game. That's all proof of work is I'm thinking of a random number. If you can guess it, I will give you whatever the state of the network's block reward is. Okay, and then so every 10 minutes there's a new block. So each block has a singular recipient awarded to kind of finalize that transaction and then put it in and write it into the ledger. Okay, and that's all Bitcoin is. It's every 10 minutes, all miners throughout the globe are playing this game. Okay, now why are people asking why is it worth it? In the early days of Bitcoin, you can follow this chart. This kind of covers the last 16 years. Okay. Bitcoin is like kind of like a incentive network. You can receive it by two separate ways. Pay for it or mine it. Okay. And so if you're not willing to pay for it, you can mine it. Just build a special computer that can do these calculations and produce these guesses to the network, and connect it to the nodes, and you can start running mining operations. Now, in the early days, a lot of miners were done on home computers, right? As you can see this chart, this is essentially what's called the hash rate index right here. Okay, what this is displaying is as the price of Bitcoin, this is displayed in logarithmic trends, okay? As it's increased in value over time, that the hash rate has gone parabolic as well. Okay, it's gone exponential. So it started off slow and steady, growing, and you can see it never really, if you follow this little yellow right here, right, as I'm scrubbing low, all it's doing is increasing 20, 30, 100 petaflops. Okay, 100, 280 petaflops. Okay, what that is the amount of calculations per second being introduced to the computer. So think of like the computers can only do so many math calculations at any one point in time. So if you bought a computer in recent past and you kind of savvy to what the tech specs are saying, your computer has a certain CPU mathematical computational capacity, and it's measured in hertz. Okay, and so that is your computer's brain's ability to calculate in binary machine code all those calculations very, very quickly. Okay, this is no different. So when the Bitcoin mining network first started, miners were getting introduced. These are machines, okay? Each machine can only handle so many flops, computations per second. And then over time, as the value increased, it incentivized more people, like a gold rush, to come into the market. It brought in more competition. Now, Bitcoin's network naturally price adjusts. It doesn't price adjust. Price adjusts based off supply and demand. It has a difficulty adjustment based off of how many people are doing computations. Okay, so if you come in and you say, I can build a computer that can do computations faster, smarter, more efficient at a lower energy cost, great. You add that to the network. Now those computations now make the network more difficult for everyone else to compete. So it becomes this energy cycle of trying to chase higher energy and chasing energy and computations. Okay, and so that's what you're kind of seeing is this trend of increasing trend of nonstop increase trend of hash rate increasing. So it starts off at teraflops, then gets to petaflops, and then this I don't even know what this exit hash, which is, God, I think trillions. If you wrote out all the zeros, it would be, I think, trillions of computations. This is per second that's doing in the network. So you can see how it just goes parabolic and it's still increasing. So it doesn't really have these little drawdowns. Even in the worst bull market, not that many miners came offline. Like at the peak of the last bull market, you saw this draw up right here, right? And then it drew down. Okay, so there the market was saying people were selling. It was probably retail investors at that time. But what we're seeing right here, there was barely a little bit of a off, barely any few miners shut off at that time, right? So, and then it clicked back on and it was off to the races again of hash rate increasing. Okay, so hash rate is the amount of computations that are being produced to the Bitcoin network. Okay, and you see it, it's like, well, the competition's saturated. It kind of is, right? But it's still open for, it could still be considered early, right? Mining's a great way to earn Bitcoin. It's essentially, think of it like an energy converter. Okay, so computations. So what is SHA-256? SHA-256 is a algorithm that mathematically converts any string or any computer string or digit that is a integer into essentially a kind of a 16-digit string of data. Okay, so what I'm going to do is I've opened up my replit and I'm just going to show you a basic SHA-256 computation. Build me a SHA-256 text and number converter. Okay. So what I asked it to do is build me a SHA-256 text and number converter. Reason is I don't want to bother coding this, so I'll let the agent do it. So it's going to work for a couple minutes. It's building up a plan right now. Yeah, you can make this into a web app. It doesn't have to be pretty. Just make it clean and simple. I would like a text field, and then under that, anything that gets typed into essentially the text field, it could be kind of like a whitish box for long descriptions. I want you to display the 256 conversion on screen. Okay, so what I asked it to do is it's just building me a simple web page, and it's going to give me a text field. It should be keeping it nice, clean, and simple. So hopefully this gets built out really fast. And it's going to bring in the hash library, probably from either TypeScript or we can do the whole thing, I don't care. Either TypeScript or Python. I've used it in Python before. And what I wanted to do is just show you a simple what is happening in the background. Not the background, but kind of like what is happening. This is a nice chart. I don't know if this is live. Kind of close. Close-ish. Let's see. This bull run might be almost over. Go back to all right, so while it's working, let's talk about mining. Why does Bitcoin get more difficult? The reason is the network is specifically designed to produce a block every 10 minutes of time and then write a transaction block into its ledger every 10 minutes. So if people were introducing more computations into the network, it wouldn't uphold that. There wouldn't be a kind of a finite demand of energy. People would just be able to spool up faster, more efficient computers, and there wouldn't be a lock-in cost to earn something. So if you go to work, right, for a paycheck, you're expending your labor, your life force for amount of time for a paycheck. So that's why like we value our jobs and our trades and our work so much, and money has so much impact to us because we've traded our life force energy. Now, in order to make a digital good have economic value, you have to pair it with some kind of energy. Okay, you can't just make it efficient. To actually create demand and actually create toughness to it, you actually have to pump in energy. So Bitcoin, essentially, a miner operates as a energy converter, and then turns electrical energy into digital energy, and then actually that can store. So what is happening is, as more computations are coming in and it's easier, think if it's like, okay, if you were with a group of people and there's 3 people and I said, I'm thinking of a number of 1 through 10, and there's 3 people, you're like, well, we're going to get this pretty quick. Like, yeah. And then now add in 100 people and they're all spitting out numbers. You're going to get there faster, right? But well, how do you make it more competitive for 100 people? We're like, well, now I'm thinking of a number between 1 and 1,000. All of a sudden that guessing game gets a little ever so trickier. Okay, so as more hash power and computations, or think of them as guesses that any miner can do in this ever expanding guessing game, it's making the optionality of the difficulty of the number harder and harder. Okay, so I think my thing, okay, so here's going back to my program, here's my simple web page. So the hash output will appear here. So if I type in the letter H, what you can see here is a algorithm is running on that one character and converting it into a SHA-256 hash string. Okay, and so this is how the hash computations work. They're producing these at trillions and billions, trillions a second. Okay, and then let me say A. If I said A again, it should be the exact same number, if he's not messing around with my program. A, if we look at 559 FFD, for 559 here and FFD in the back, if I close this, go capital A again. So each character produces a unique hash string, only unique to it. And this is essentially how databases store our passwords. When it says type in your password and you're like, well, my password's wrong, and you forget that your password is character specific. Let me show you. Here's a lowercase. Notice how the hashing computation is different. What SHA-256 is it's just a cryptographic algorithm that essentially takes known characters and then makes it into scrambled garbage that's hard to read. So let's say I can write anything in here. So hi, my name is Derek. If there is a viewer right now let's give them the name Freddy. So as you can see, as I was typing away, the hash stays the same length and character length, but is ever changing. So you can write whatever full document of your life story, your full biography. You could live up to 150 years old, and it would still convert to the same characters no matter what. And I can infinitesimally keep type forever, and it'll just keep computing new hashes for every character I choose to type in this novel right here. Okay, so now think of this. You saw all those hashes? That's all these flops. Okay? That's what the miners are trying to do. You're thinking of a number, and it's trying to produce this, but it's converted into this. And it's going like, boom, 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 boom. Is it this? Is it this? Is it this? And just trying to guess the number. And the machine is like, well, you need to be accurate to at least half of these. And then you have to end in 4 digits the same here. So there's a difficulty of the number of like where your token's being pulled, where you're winning the lottery of your guess. And so that's the game. That's mining in a nutshell, is this guessing game of people bringing in computers that can do these computations in this kind of language. This is called SHA-256 hashing, and it's just a cryptographic algorithm that converts string data, like I'm typing here, into string data. This is a string data of character strings into a long character string, right? And like I said, I can type in whatever. I can put in the full Bible, and it will have one specific output. If I change any of these characters that I just typed, let's say this G into a capital D, the character string is no longer the same. So hashing, boom. And to kind of show you again what it would be, what like hash rate looks like, is if I were just to type, see all the numbers changing very quickly as I'm typing. That is essentially your computer, but the network's doing it in trillions per second. So I'm going to delete all this. Bob, all caps, 55279F5DD420. Cool. So now all right, now that we have this converter, build me another part of the page that is essentially a kind of like the miner network. I have a start and stop button to kind of start the miners from going through their hash rate guesses, and there on the opposite side is let's make this into kind of like a game. Okay, so this game is someone is guessing the hash number, and then someone is essentially creating the hash number and confirming it. Okay, and then as I press we have 3 buttons. We're going to say we're going to have a start and stop of the game. Okay, and then the difficulty is set by a button that says I can click, and what it does is it's going to essentially add in another player. And so for every player, we're going to make it more difficult. So we're going to make an exponential trend. So we're essentially going to square root the number. Okay, so if there's 2 players, it's 2 squared. Okay, and so that's going to be the difficulty ability. Okay, so this game is essentially going to have someone trying to say they're going to just guess out a hash. Okay, and they're gonna, and it is, and then as I increase the players, there's gonna cycle through, right? Let's do one every, let's do a couple, let's do like 32 guesses a second, and then or put a button so I can change the speed of which the guesses are, and then put in the same guesser. So we don't want to make it have to be a 1-for-1 match. Okay, so as we start, level 1 is my guesser bot only has to match 1 character. Okay, and then as we exponentially increase, they have to get more and more mathematically closer to the guess. Does this make sense? All right, so I just kind of talked through my new idea. Okay, I'm going to see if it can build it out for us. So what I'm going to show is kind of a core couple functionalities. We're going to have a game that's being played using the SHA-256 functions. Okay, and all these computations are going to be handled locally. Okay, I'm going to have a start and stop function. We're going to have a speed dial to increase the hash rate. And then we're going to have a button that allows me to increase the number of players. And as it increases the number, the difficulty of the number increases. So we'll give it a couple minutes and see if it can work. So why are people asking why, if Bitcoin mining is profitable? It's just like any business. Okay, I think a lot of people think, oh, like back in the day, I could have just turned on my computer and I could have just ran a miner off my computer and it could have just ran these programs in the background. Well, now not anymore. You can see that hash rate has increased exponentially over the 16 years of its life. That game is no longer viable. Okay, you can't just spool up a program doing hash functions on your personal computer. You need specifically really intense devices that burn up a lot of energy. I have one in my room that I'm doing some maintenance on. The processors on this board produce a insane amount of heat. It is like a little heater box. When I turn this sucker on, and it's not even a full thing, it's just the Apollo future bit. And this is a really stripped down miner for today's standards. And it produces a lot of energy. Like, it gets warm. It's enough to noticeably warm my office space when it was on, where I had to keep the fan on just to kind of keep the room space kind of chilled off. And so that was just that device. Now you add in tons of these centers where they have hundreds or maybe thousands of miners that are 500 times more powerful in their hashing ability. That's a lot of calculations, very fast, producing a lot of power and a lot of heat. And so you're utilizing a lot of energy to be competitive in the market. And remember, this is a guessing game. So essentially the first one to the correct number wins the block. Okay, so it's like so people are building sports cars, essentially computers that are specifically designed. So the mining market kind of got away from everyday consumers, essentially. People could still do it, but you have to connect with mining pools and share the costs. What essentially it is if the mining pool wins, you distribute the earnings for producing a little bit of hash power to the network. Okay, remember, it's all about grouping the ability to guess. So instead of your one miner working solo and never being able to do enough computations or having, you know, 1,000,000 to 1 odds of winning a computation block, you've decided I'm going to share the load of my costs. So you hook up to a pool, you hook up your miner, it converts some energy, and you run it for enough time. You maybe get a couple cents here and there every single day, and it creates this payout. So it's all of this is a business. So it's hard to operate a business to figure out your energy costs, your costs of your miners, your costs of production, figuring out your financing, how you're going to financing these things. Newer miners today cost like $10,000 to $20,000 for just one box. Now multiply that by a couple hundred. They're hard to come by. Chips are hard to come by. Cheap energy is hard. So there's this very, very dynamic game that miners are playing. And so if you're just trying to get a little bit of side hustle money, mining has kind of done away with that. Not that you can't. It's all doable, but again, the surge of the Bitcoin price brought in all this competition to bring in more and more hash power into the network, and it drove up all these costs. So you have to be a big spender to be a profitable miner nowadays, versus if you just have the cash, you could just invest into Bitcoin and earn it the same way. But miners think they if they got cheap energy, they can get essentially Bitcoin on a discount if they have access to cheap energy. So let's check up on our converter. So our mining network game. So you have network status, we have players, difficulty, still working. Right now it's testing. All right, so we have match level, 0 attempts. So target hash, 6. So let's see if it starts working. Start mining. 46 attempts before it stopped. 56. Okay, so that's the thing. So see, that's one player getting 1. Okay, so now add a player. Okay, 6C, target hash. Okay, right here, it's showing the 2 miners working to get that right number. Match found, match found. Okay. Boom. Okay, reset. Let's go add a player. Okay, so now they have to go to 3 digits, 3 players, all working. Let's see, start mining at 32 guesses a second. How quickly one of them gets it. And all they have to do is get one of these strings in the right order. Right now they're at 400. As you can tell, it can, with this rate of speed, it can start taking a while. So let's see if we can go faster. Now 64. It's loading. Okay. Let's go 64 guesses a second. Let's go 500. There you go. Boom. Instantaneous. With one player. Let's do 10. Okay. Start. So 10 players now have to guess a string of 10 characters long. They're guessing at 1,224 each a second. This is the amount of total attempts so far. And one miner got it, I think. No, no one's got it yet. So this is just a simple little game. Okay, we can see the target, right? This hasn't changed at all. We've just established this is the target hash of my guess. Okay, I'm just a simple, let's say I'm just one of these guys, right? I have one device, and my device is just making all these attempts. It's just, you can see it's pumping through all these different calculations. Like, is it this, is this, 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 this. Random sequencing. It's running through 1,200 or 1,024 guesses a second, which I don't think is correct because maybe it's running through all of them. So as of right now with this difficulty, no one has got it yet, got the win yet. So who knows how long we can go for, but this is kind of the nature of the game. Okay, and if I kept adding miners, let's see if we can, how many miners we can add. I'm gonna add 100. And as you can tell, my program is starting to slow down. It's hard to kind of simulate. So with this miner, they all have to get their exact right string, and total attempts is the 30,000s, and no one's got it yet. So they can be at this all day because this can be any number of sequences. So this is the nature of mining, okay? All these different individual miners are all just doing these computations, trying to get to the one digit so they can be rewarded. It's not overly complicated of a concept. I hope this was insightful and educational for you and interesting. I hope you guys enjoyed kind of my rough explanation of all this stuff. And yeah, this is a simple little try, repl it out, test this out, see if you can guys build this at home yourself. This is just a simple explanation program, nothing crazy. I'm not even going to publish this. I just wanted to show you guys this so you can see what a SHA-256 is. A, B, C. Anyone get it yet? None of the miners have got it. So I'm going to stop the game at that and close out this program. I hope you guys enjoyed this stream. I hope you guys have a wonderful day. See ya.